Hello, lovely humans. Today we are going to review some right triangle trig. So SOHCAHTOA should be ringing some bells coming back to you, hopefully. So this should be a brief review of right triangle trig that you learned last year. So just a brief reminder that sine of theta, which is this little symbol here we call theta, sine of theta, that's an angle measurement, is equivalent to or equal in value to the opposite side of that triangle divided by the hypotenuse of that triangle. So remember, when we talk about opposite, we're talking about the leg of the triangle that does not touch the angle in question. When we're talking about adjacent, we're talking about the value that does touch the angle. So if we're looking at theta right here, adjacent, notice, touches that angle there, whereas opposite does not touch that angle at all. And hypotenuse, of course, is always opposite. Ooh, that was ugly. Okay, slippy hands. Opposite the hypotenuse. Okay, so again, theta we use to represent an angle measurement, and those ratios are of the side lengths. Okay, so we talked about that. Okay, don't forget inverse trig is also going to come into play here. So when we're solving for an angle, we need to undo that operation of sine or cosine or tangent, right? So if we have sine of an angle and we want to solve for the angle, so undo that sine operator, we're going to use what's called inverse trig, or sine to the -1. That -1 representing inverses, just like when we did f of x, or f to the -1 of x. That -1 is often used to represent inverses. Okay, so let's actually do some of this. Again, hopefully this should be a review, and we're going to remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. Okay, all right, so always identifying our hypotenuse is opposite our 90-degree angle. So the angle we're given here is 41. Of course, we could also solve for this other angle over here, because remember, all triangles add up to 180. We know we have a 90 and a 41, so we could definitely solve for angle B if we wanted to. But let's use trig. Okay, so if we wanted to solve for this x value here, we're going to use both the legs and not the hypotenuse, because I'm given one leg and the leg I need to solve for, neither of which are the hypotenuse. So we want to use an opposite over adjacent. Opposite over adjacent sounds like tangent to me. So we're going to do tangent of this value 41. 41 is equal to opposite, which is 4, not touching that angle, over the adjacent, the non-hypotenuse that is touching that angle. All right, so now we can actually solve this. This is really ugly, and I'm going to fix it. Make that a little better. 41, right? So tangent of 41, we're just going to enter that into our calculator. So again, really, really important that your calculator is in degrees and not in radians. When we get into trig in the future, we'll switch over to radians, but for now we want to find the degree measurement, so we're going to keep our calculator in degrees. So make sure you're in your mode, wherever that is for your calculator that you're using, or Desmos online. Make sure you're getting a degree out. Okay, so we're going to take tangent of 41. We are going to cross multiply by x, right, because we need that x to the other side. So we're going to have it, try again. We're going to have x times the tangent of 41 is equal to 4, but we want to solve for x, so we're going to divide, that needs a 1, by the tangent of 41. So over here, we're going to divide by tangent of 41. So I'm going to take 4, divide by the tangent of 41, and see what we get, which is about 4.6. And then I want to ask myself if my answer makes sense. If one side of my triangle is 4, the other side definitely could be 4.6. It's not the hypotenuse, so it's not going to be the longest leg. That looks good to me. Okay, so our x value here is approximately 4.6. Okay, I said to solve for all the parts though, so let's solve for our other parts as well. If we wanted to solve for that h, the hypotenuse there, you could use Pythagorean Theorem, right? Because we now have two sides, so we could do 4 squared plus 4.6 squared. Now this is not going to be exactly perfect because we rounded our 4.6 answer. is equal to h squared. If you wanted a more exact answer, you could actually use right triangle trig again. But we can do it this way to give us a general idea. So we have 4 squared plus 4.6 squared. And then we need to take the square root of that to actually solve for the hypotenuse, right? So we're going to take the square root of that answer, and we get 6.09. That sounds good because the hypotenuse is going to equal about 6.09. Okay, and that makes sense given information. To solve for that missing angle B, super easy. We're just take 180, right? 180. We're going to subtract our 90 because we have a 90-degree angle. We're going to subtract our 41, and that'll give us our angle B measurement. So once you have two angles, obviously it's super easy to solve for the third one. Okay, this triangle is actually a 30, 60, 90 triangle. You can use right triangle trig on it, but you can also use special right triangle rules if you remember those. Either way would be fine. In this case, I said right triangle trig, so I'm not expecting an exact answer. I'm expecting a rounded answer. If you use the rules of special right triangles, you can actually get me an exact answer. Okay, so and now we're given the hypotenuse, right? We have the hypotenuse there. And then we know this is 30. We know that's 60. We're trying to solve for x here, which is adjacent to that 60 value that I did. So now we have adjacent over hypotenuse, which sounds like cosine to me. We're going to do cosine of 60 is equal to adjacent, which is that x value, over the hypotenuse, which is 11. So I'm going to take cosine of 60 in my calculator. We are going to multiply that by 11, and we get that our x side length is about 5.5. Or actually, it looks like it's exactly 5.5, which is convenient. Again, we could use Pythagorean Theorem to solve for the other missing side, or you could use right triangle trig. Again, give that one a shot. All right, let's solve for x in this one. So now we have adjacent and adjacent and the hypotenuse. Again, that's going to be a cosine, just like this last one. Because I want to use a different trig operator instead of cosine, because we've already done that one, I'm just going to go ahead and solve for my missing angle there. So if I take 180 minus 37 minus 90, or of course you could just start with 90 if you wanted, would be 53. That allows me to use sine instead if I wanted to. That would be opposite over hypotenuse. Just another option there. So we could do sine of 53 equals 11 over x. This is similar to that first one. First, we need to move the x to the other side. Multiply by x, multiply by x. Then we want to get rid of that sign. We end up is x equals 11 divided by the sine of 53. Again, you could have set this up as a cosine problem, and that actually would have been slightly simpler to solve, but I just wanted to show you another option. Lots of options with these. So now we're going to take 11, we're going to divide by the sine of 53, which gives us approximately 13.77, so about 13.77. And that's my hypotenuse. That should be my longest leg. So if you solve for the side CA, double check that it is in fact shorter than your hypotenuse of 13.77. All right, last but not least, give this one a shot. You're given angle A. We have opposite over adjacent here. So this is another tangent. Tangent of 32. Again, you could solve for that other angle and use a different trig operator and get the same answer. It's going to equal x over 13. Cross multiply, we're going to take tangent of 32, and we're going to multiply that by 13, which gives us approximately 8.12. Okay, so hopefully this is making sense and we remember how this works. Okay, slightly more complicated, but still pretty similar is solving for the angle. Okay, so this is where we're going to have to use that concept of inverse trig to undo the trig operator. We're going to use inverse trig to isolate that angle there. Okay, so what am I given to the angle? I have opposite and adjacent. So we got another tangent here. So now we're going to do tangent of theta is equal to opposite 11.9 over adjacent, which is 10. Okay, so I need to undo that tangent operator. So undoing that tangent operator is by using inverse trig. So we're going to use tan -1. That's going to cancel out the tangent over here, isolating my theta. And what I'm going to be left with is that theta will equal tangent -1, the inverse of tangent of 11.9 divided by 10, applying that inverse operator to the other side because we applied it to the left to undo that tangent. So of course we apply it to the right, just like we do with all math. So now we're going to take tan negative 1. That's the second. If you're using a typical graphing calculator, second tangent. Again, it'll say that negative 1 above it. So we're going to do second tangent and then enter our 11.9 divided by 10. And that is going to give us about 49.96 when we round, and that's a degree measurement. That is angle A. So that's the measurement of angle A. Okay, now we could use the principles of, or triangle sum theorem, right? All angles add up to 180, so we could subtract 90 and our new angle of 49.96 to solve for our missing angle B. We could also use Pythagorean Theorem to solve for our side AB if we wanted to do that. All right, give this one a shot on your own. We're solving for theta. We are given adjacent and hypotenuse. That sounds like cosine to me. Cosine of theta equals adjacent, which is 4, over the hypotenuse, which is 5. We're going to use inverse trig, so we're going to get theta equals cosine negative 1 of 4 divided by 5. We're going to take cosine, second cosine, the inverse of cosine, and take 4 divided by 5, and see what we get. We get that the measure of angle C is approximately 36.887 when we round, 36.87. Again, feel free to solve for all the missing parts to practice your skills. Okay, now we have this angle here, and we have, again, adjacent over hypotenuse. So this is going to be, again, a cosine. Cosine theta equals adjacent 12 over hypotenuse 13. Cosine negative 1 of 12 over 13 is going to give me my theta value. Arc cosine or inverse cosine or cosine to the negative 1, all the different ways that we talk about inverse trig. So you might hear someone say arc or inverse or cosine to the negative 1. All of those mean the same thing. So this angle, theta here, angle A, right? Angle A, also known as theta, aka theta, is about, get it together for now, it's about 22.62 when we round. And again, then you can solve for all the other missing parts. Okay, this looks like an isosceles right triangle, which means I know theta has to be 45 because I know this leg is the same as this leg. That only happens if you have an isosceles right triangle, because the only way the sides are going to be exactly the same is if the opposite angles are exactly the same. But let's use trig to prove it. Just another way to prove that we are doing something correct. So we're going to take sine, opposite over adjacent is going to be tangent, right? Tangent theta is going to equal 3 over 3. So we're going to use tan negative 1, arc tan, or inverse tangent of 3 over 3, and let's see what we get. And 3 over 3 is just 1. So really what we want is the arc tan of 1. And what is that going to give me? 45, shock of your life, right? So we know that we get theta is going to be equal to 45. That means also that angle A is 45. And then you could use Pythagorean Theorem to solve for the hypotenuse. Hopefully this is a review and makes sense to you. Have a wonderful rest of your day.